G'day, I'm Dr. Kev, and in this video we're going to be looking at product design specifications and opening up our conceptual model in SolidWorks and seeing how these specifications have led to some of our major design decisions. Welcome to Car Design Workshop. So a product design specification is part of the design process, and in particular we've been looking at the application of Pugh's total design to the design of a custom sports car. And this document is a live document that covers a lot more than just the intended performance of the vehicle. It will cover things like the manufacturing techniques that are going to be used, materials that might be applied to the vehicle, legal constraints, things like the documentation and testing that you're going to require for the vehicle, and a lot of other specifications that are relevant to the design of the vehicle. And these can be put together as dot points that can be updated as the project continues. And this is particularly important as we head into the conceptual and detailed design phases, where new information is undoubtedly going to affect our specifications. Now, in previous videos, we've discussed some of the performance targets of this vehicle, but in this video, I want to cover some of the other aspects of the specification that have influenced some of the major decisions that have been made in this project so far. Now, one of the first questions you're going to ask whenever designing any sort of product is, what sort of environment is it going to be used in? Now, this car is going to be built in Perth, Western Australia, and Perth is a hot, dry location. We only get about 100 days in the year where there's any sort of rain whatsoever. And this provides a really good opportunity to create an open-top car or a speedster. Now, previously we have mentioned the desired performance of the vehicle. We are aiming for a 0 to 100 time of less than 6 seconds, and probably something that's cornering at between 0.9 to 1G cornering on normal road tyres. And to achieve this with a relatively low budget, that's going to mean we're going to need a small car. A small car is a lightweight car, and a lightweight car that wants to accelerate at a reasonable speed is going to need a less powerful and, more specifically, a less expensive engine. So in the specifications, we chose a size that's representative of one of the benchmarks we chose, the Porsche 550. Now, this is a starting point for the size of the vehicle, and as we go through the project, this is undoubtedly going to change as we start doing the conceptual and detailed design of some of the components and systems of the vehicle. Speaking of budget, the budget for this car is, and I might need to bleep that out, my wife does watch these videos and I don't think she needs to know all of the money stuff just yet. But to put it in perspective, some of the benchmarks that we chose are listed here, and we have an idea of what they cost. So one of those benchmarks was a Mazda MX-5, and new they go for 50 to 60k Australian. A Lotus Elise at the moment you would be looking at between 50 and 140k, and an Austin Healey between 60 to 90k. Lotus 7 style kit car, anywhere from about $25,000 to $50,000 Australian. So that gives a fairly wide range of between $25,000 and $140,000 Australian. Now, obviously, when we start these projects, sometimes it's necessary to be a little bit optimistic with the values we're going to use for our budget. Otherwise, we might not be stupid enough to even start the process. But there are ways to keep the costs down. One of the ways that we can keep the costs down on the project is to get as many of the, complex and powertrain style components from a donor vehicle. And this is relevant to a lot of the other parts of this specification document. For example, when we look at the life in service and the maintenance of the vehicle, if we're using a donor vehicle, it means that we're going to have accessibility to a lot of spare parts, especially if we're choosing a donor vehicle where there's quite a few of them that were made. And we're also going to meet some of the requirements around the registration of the vehicle, where many of the parts and systems are going to need to be compliant to Australian Design Rules, or ADRs. These have been summarised in Vehicle Standards Bulletin number 14, and there's a lot of documents here and really too much to unpack in this video. Another thing a donor vehicle allows for is a more reasonable timeline for the project. It's great to have a lot of really customized parts, but every time we're doing a customized part or system, it's going to add time to the project, where a really suitable part or system from a donor vehicle can cut that back quite a lot. And I actually quite like the idea of recycling a vehicle and reusing some of those parts and repurposing them, much like we see with the Austin Healey, where parts were originally designed for a much more mundane vehicle and then found their life in a much more exciting sports car. And that's something that really appeals to me. And thinking about these issues of budgets and timescales and what's likely to be possible in this project, where we want to keep the quality quite high, it's going to be very important to make sure that this car has really the minimal number of systems it needs to perform its duties and to be the car that it should be. A minimalist car is going to be a lightweight car, which is going to be great for performance, but it's also going to be a car that's cheaper and takes less time to design and build. Now, just how minimalist we want to make the vehicle is going to be something we're going to need to explore later during the conceptual and detailed design phase. For example, we could minimize the systems on the car by removing something like doors and just having a car without doors. And it's going to avoid all of the extra safety requirements around the structure of the door. But it will mean things like it's much harder to access and get in and out of the vehicle. So we're going to see these sorts of decisions, sort of knock-on effects of these as we go through the projects. And really, sometimes we're going to be revising even some of these early decisions as the process continues. Another example of creating a minimalist car would be to eliminate seats and to mold them into the structure of the chassis. And when we look at these sort of approaches to minimalism, we start to see conflicts with other parts of the specification. For example, one of the specifications is, I would like this to be a vehicle that my wife can drive and enjoy driving as well. Now, one of the problems with that is that in imperial units, I'm about 6 foot and my wife is about 5'2". And that means there's quite a sizable difference between us driving a vehicle. There's going to be very different ergonomics requirements. And that's going to be very hard to meet in a minimalist vehicle if we're not including adjustability in the controls and things like adjustable seats. So at this stage, we know that the car is going to be a small minimalist speedster that uses a lot of components from a donor vehicle. And this later design decision or design direction really leads to another fundamental decision, which is that this car will be a mid-engine vehicle. As soon as we accept that we're going to need a fairly modern donor vehicle and something that's going to be reasonably affordable, it means it's likely to be a front-wheel drive vehicle with a front engine. Now, it's fairly obvious that we're not going to be building this car to be a front-wheel drive vehicle. It's something I'm almost certainly going to cover in a later video when we start to get into vehicle dynamics. So the most obvious way to turn a front-wheel drive powertrain into a mid-engined rear-wheel drive car is to take the powertrain and the engine from the front of the vehicle and move it to the rear of the vehicle. Now, this has a couple of really good advantages. The first is that the engine ends up being quite close to the driver, which makes for a low polar moment of inertia of the vehicle, which is going to help it accelerate or rotationally accelerate into corners. The other is that it's going to end up with a lot more load on the rear tires as the center of gravity is more rearwards. And this is going to mean we're going to have more grip under acceleration conditions, which is going to make that acceleration time of sort of 0 to 100 in 6 seconds much easier to produce when we've got that extra traction. Now, there are a lot of other things that are really quite important in the specification documents, and one of these is that this car is intended to be driven. It's not going to be a show car, and that's really going to come into play with the level of quality we're trying to achieve. One of the things I really like in cars is what I'd call truth in materials, where the materials are really what they're supposed to be. If the vehicle is made from aluminium, maybe you are keeping that aluminium in the bodywork as raw aluminium, or you're painting it a light metallic color. You might be using leather. You're going to make sure that that is not a garish color, that it's closer to a natural color that the leather might be. And if you're using bits of wood as accents in the vehicle, so a wooden steering wheel or a wooden gear stick knob, that you're using fairly simple finishes on those components. Now, there are some parts that this specification doesn't make obvious. For example, I don't really know whether this car is going to be a space frame vehicle or use a composite monocoque, and I'd really appreciate your comments and feedback on which way you think this project should go. In some ways, I feel far more comfortable building a monocoque chassis or composite structure. I have some experience building structural composites, and I'm a really bad welder. So it really does point me in that direction to sort of as a starting point. Now, the main downside of using something like a composite material in the chassis is just the cost involved. And there is a bit of an overhead when we start to look at the testing required to prove structural rigidity, structural strength, and some sort of equivalence to a steel structure. Now, there's a lot more decisions to be made in this project, and there's a fair amount of time required to do that. But even going through the specifications, we've been able to clearly show that what we're trying to build is going to be a small, minimalist speedster that has extensive use of donor components. And these components are going to enable us to meet both our performance targets as well as some of our legal requirements for the registration of a vehicle like this. Now, I didn't want to bore you in this video by going through a step-by-step run through of a product design specification, but I hope I have showed you some of the more interesting ramifications of this document and how it's influenced some of the major design decisions, as well as it's been really good to show you some of the images of the conceptual model so far. If there's anything that you feel I haven't covered here, or you've got questions about on some of this product design specification, feel free to comment on the videos as you're on your way to subscribing and liking this, and I hope to get back to you and respond to them as I can. Thank you for your time.